The same model that writes a courteous patient message draft can be the wrong model, provider, or permission profile for a literature brief or coding support task. Because in clinical AI, the route to an answer is part of the safety decision. The output alone does not tell you whether the work followed an approved path. That is why an impressive paragraph is not enough evidence of a safe system. You will learn to separate a model from its provider and from the profile that grants access, match those choices to 3 common clinical tasks, and design a fallback that preserves your clinical controls rather than quietly changing privacy, evidence, or authority when the preferred service is unavailable. You will also see why the same task may need a deliberate stop rather than a fallback. The choices that compound are often invisible when a chat window produces a good paragraph. Yet an agent does not exist as a single thing called AI. It operates through a deployment environment, a provider, a model, a profile, persistent state, and a permitted tool surface. In a clinical setting, each layer answers a different governance question. A model produces text. Models differ in cost, context length, instruction following, tool use, latency, and behavior on ambiguous tasks. A provider is the approved route through which that model is used. 2 routes to a similarly named model can have materially different contractual, geographic, logging, retention, security, and support characteristics. Do not assume that a model name tells you where patient data travels. A profile is a named operating configuration for an agent. Think of it as the role card for a particular clinical work surface. Which instructions it loads, which tools it can see, which credentials it may use, and which delivery channels are enabled. A profile is useful segmentation, not complete security isolation. PHI workflows still require appropriate infrastructure, service accounts, network boundaries, audit logging, and a verified privacy posture. A better architecture uses narrow profiles and task-specific choices. A clinical research profile may have search and literature extraction tools, but no patient connector. A patient communications draft profile may read an approved task packet and create a draft in a review queue, but cannot send. A billing support profile may read finalized documentation and payer rules, but cannot modify coding or submit a claim. Prompt caching is part of why this structure compounds. Providers can reuse the stable beginning of an agent's prompt when it stays unchanged. In Hermes, stable instructions, skill index, and tool guidance are assembled ahead of context and volatile session information. The stable prefix is like a standing order set for the workflow. It should not mutate halfway through a case. It gives instructions a clear place and precedence. Provider fallback also needs translation. A fallback is an approved alternate route if the preferred provider returns an error or reaches a capacity limit. In consumer software, fallback may be a convenience feature. In clinical work, a fallback can be a policy boundary. A research job may fall back to another approved non-PHI research provider. A PHI task should not automatically fall back to an unapproved endpoint because the first call failed. The correct behavior may be to stop, preserve the request, and report that the approved service is unavailable. Finally, persistent sessions and working tools matter more than a clever first prompt. A session store preserves the non-patient work trail across restart. Draft status, review notes, approved templates, and operational context. But the presence of a session store is not permission to accumulate a shadow chart. The patient record lives in the EMR or FHIR source retrieved for the specific task. The agent's durable state should contain workflow knowledge, not a parallel clinical record. Consider 3 tasks that are often lumped together as asking AI for help. They should not share the same architecture by default. A regenerative medicine literature brief, a patient message draft, and billing coder support. Task 1 is the literature brief. The physician asks, prepare a source-linked review of current peer-reviewed literature relevant to a proposed orthobiologic discussion. Separate human clinical evidence, preclinical evidence, regulatory context, and unanswered questions. Do not generate a patient-specific recommendation. This belongs in a clinical research profile. The profile has web or licensed literature search, document extraction, citation verification, and a local brief writing tool. It does not have access to the patient chart, portal, e-prescribing, or billing system. The task does not require PHI, so the provider choice can be optimized for strong, long context reading and reliable tool use within the organization's approved research posture. The model must be capable of extracting claims without collapsing study design, population, comparator, and outcome into promotional prose. The agent starts with a stable research skill. It defines evidence tiers, requires a source link for every material factual claim, and requires an explicit not established section when evidence is indirect. The tool loop searches primary publications, guidelines, regulatory sources, and payer documents as appropriate. It stages a brief with authors, year, journal, study design, population, and limits. If a cited identifier cannot be validated, the claim remains unverified or is removed. The physician then reviews the brief before using it in education, consent discussion, or care planning. If the preferred research provider fails, the system may use a pre-approved secondary research provider that receives no patient data and has the same citation verification gate. If the search connector is unavailable, the job may return a partial brief with a source coverage warning. It must not convert incomplete retrieval into an authoritative statement that the literature is silent. Task 2 is a patient message draft. Imagine a physician has already reviewed a laboratory result and wants to prepare clear, empathetic language for the portal. Do not add diagnosis, triage, dosing, or new recommendations. Stage only. This belongs in a patient communications draft profile. The profile should use the clinic's approved PHI pathway if PHI is involved. Do not add diagnosis, triage, dosing, or new recommendations. Stage only. This belongs in a patient communications draft profile. The profile should use the clinic's approved PHI pathway if PHI is involved. It may receive a narrow task-specific packet, not broad longitudinal access. Its permitted tools are intentionally modest. Read the approved packet, apply a readability check, and create a draft message card. It has no send message tool. If it has access to the portal at all, that access is read-only or draft-only, governed by a separate service account. Here, model selection is less about maximum reasoning depth and more about faithful instruction following, tone control, and low hallucination under constraints. A quick, economical, approved model may be appropriate if it reliably preserves the physician's meaning and the output is always reviewed. The main safety control is the input boundary and absence of delivery permission. If the chosen provider is unavailable, the draft does not move to a consumer endpoint or alternate geography automatically. The job pauses with a visible status: draft not generated, approved provider unavailable. The physician can write the message directly or explicitly select another approved route. Convenience never authorizes a silent data path change. Task 3 is billing coder support. The request might be, compare the finalized encounter documentation against the payer policy checklist. Identify documentation elements that may support or fail to support candidate coding. Return questions for the clinician or coder. Do not choose a code, alter documentation, or submit a claim. This is a distinct profile because it touches a different risk domain. The agent may need read-only access to a finalized note, a current policy library, and a coding rule reference. It should not read the whole chart by default, and it should not have claim submission permissions. The output is a staged coder support worksheet, stated documentation, policy criterion, possible gap, source, and question. It is not a coded claim. The model needs disciplined extraction and a strong ability to identify ambiguity. But provider choice matters too. The policy library must be versioned, retrieval dates must be visible, and any PHI route must meet the organization's approved posture. The system should record which payer policy version was checked. If the policy tool cannot confirm its current version, the agent should say policy currency unverified rather than cite remembered rules. Across all three tasks, the compounding architecture is the same. Stable instructions are kept stable. Skills are selective. Profiles narrow the tool surface. Providers are approved for the data class. Models are chosen for the work, not the demo. Session persistence retains workflow state and review history, while patient facts are retrieved from source per task. A good architecture does not make the agent universally powerful. It makes each small task reliably bounded. There is no universal ranking in which one model is simply the clinical model and another is the cheap model. Benchmark performance does not establish safe behavior in your prompts, your connectors, your patient population, or your failure conditions. A model can be excellent at extracting a study table and still be unsafe at preserving a boundary in a message draft. Evaluate the task, not the brand. Provider documentation also does not replace a formal privacy, security, contractual, and operational review. The relevant questions include data handling, retention, access controls, auditability, business associate requirements where applicable, regional constraints, incident process, and whether the actual connector follows the posture you reviewed. A profile name such as clinical proves nothing by itself. Prompt caching is not a safety mechanism. It can make a stable prefix cheaper and faster, but it cannot correct a missing guardrail or prevent a poor tool schema. Likewise, persistence can preserve an audit trail, but can also preserve unsafe material if you allow the wrong content into the session store. The durable record must be intentionally designed. The silent failure to watch for is fallback drift. A primary endpoint fails, an alternate provider answers, and nobody notices that the data route, model behavior, logging, or tool support has changed. In clinical work, the fallback policy must be explicit, observable, and sometimes intentionally inconvenient. Its limits should be tested before the workflow is trusted. Document the observed behavior and the assumptions behind it. That evidence should be reviewed before go live. The rule is to approve the route before the request, not after the output. For each profile, document the permitted data class, model and provider options, tools, fallback behavior, retention posture, and named human reviewer. Every patient-facing draft, clinical interpretation, coding conclusion, order, submission, or chart change remains staged until the accountable physician or designated authorized reviewer accepts it. If no approved route is available, fail closed. A named reviewer confirms the route as well as the content. The route must be visible in the audit trail, including the fallback decision. That verification is part of clinical governance, not a technical afterthought. This week, make a one-page routing table for 3 tasks you already perform. For each write, does it contain PHI, what sources may be read, what tool is allowed, what output is staged, who reviews it, and what happens if the preferred provider is down. Do not begin with model shopping. Begin with a boundary that a future colleague can audit. If you have only one answer for all 3 tasks, that is useful information. It means your architecture is not yet expressing the differences among research, communication, and revenue cycle work. Next, we will build institutional memory that helps the agent follow your clinic's SOPs without becoming a shadow chart. That rule is more useful than a generic preference for the newest model. Keep the first table simple enough that the team will actually use it. Make the boundaries visible to every person who might request the task and use it. This video is for educational purposes only and does not constitute medical advice or legal advice. Any implementation of AI agents in a clinical setting must be reviewed against your local HIPAA posture, state board requirements, malpractice carrier policy, and your own professional judgment. The physician remains the accountable clinical decision maker.